Okay, so that's the wrong course. I'm sorry, I clicked on the wrong thing. We're going to move on to the next part because we have six they're pretty small lectures, to be honest. But we really would like to get through dictionaries and globals today, and we've got about 25 minutes. So let's have a start with dictionaries. So in Python, we have talked about a couple of data structures last week, which was, what was it, CD, content, lectures, great. I'm going to week 2, perfect. I'll make VLab bigger now, we can get deeper into VLab. So we have talked about different data structures last week. We talked about, my list, this is like a list. We talked about tuples, which is the same as list, but they were read-only. They were the main two data structures that we talked about. But there's a third type of data structure, which is extremely useful. And it's called a dictionary, right? And the way to understand a dictionary is that this is a list, by the way. Lists, kind of in their very nature, are sequential containers of memory, right? You can think of them as basically like items stacked up next to each other, and they tend to be related, and most importantly, they are indexable. They have a key, right? So you can say, I have this list, and the way I look it up is with a number. I say the first element, the second element, the third element, the fourth element. You can do some negative stuff too, where you're like, I'd like the -1 element, the -2 element. By the way, this is in the lecture slides. This is a nice little demonstration of what we talked about last week when it came to negative indexes. But they're ordered, right? There's a sense of order in a list. They have indexes, that's how you look them up, and they have a sense of order. Arrays, linked lists, Python lists, they're all like that. But there are other types of data structures that are more commonly similar to a struct in C, which are called dictionaries. And these are what we call associative containers. And what associative container means is that a container is like a data structure, but associative means that it's like a mapping. It's saying that instead of like with a list where you'll be like, hey, the first element is hey, and the second element is how, and the third element is like this. This is like a list, tuple, linked list, array kind of thing. But with dictionaries, it's more like you're mapping text or strings to values. So for instance, you're saying, name is Hayden, and age is 18, and parent is Mark G. That'll do. They're like structs, they're like hash tables, they're like objects. They're in pretty much every language in some way. They're not quite like structs in C though, because structs in C are really rigid. Like you kind of have to define them at compile time, and then they can only be that big. But with things like hash tables in languages like Python and JavaScript and Java, they're a lot more dynamic. I'm not only 8. No, I'm not 18. Mark Chi is my dad. I think Mark Chi is probably just a few years too young to be my dad. But that's how associative containers work. So it's like structs, and if you're really struggling to visualize it, it's just like structs. You specify names, and if you remember structs in C, it'll be like this. You'll be like, int char star name, and like int age, and char star parent. What you're really doing here is you're saying that I'm going to define this particular property with a name and not an index, right? So that's the main difference with lists and stuff. So let's have a look at a couple of examples of this. So if I want to do a basic dictionary in Python, and let's just look at the code. If we look at the code for this now, where is it? Dictionary Basic 1. You can make a dictionary in Python just like you can make a list. If I want to make a list in Python, I could say, this is my list, and then I could say list.append Hayden, list.append Smith, right? That's how I interact with it. If I want to make a dictionary in Python, I say that it's equal to braces, right? So this is like open function braces. This is saying empty dictionary. I'd like to create an empty dictionary now. Similar to an array or list, I can kind of populate that as I go. So you know that in Python, if you do this, you can kind of say list 0 equals like tay or something. You can do a similar thing with dictionaries where you say that, you know what, the element that's named name has the value Sally. The element that's named age has the value 18. The element that's named height has the value string 187. You'll notice that with the dictionary, I don't have to have all the values be the same. It can be numbers, it can be strings, it can be floats, it can be anything I want. It's a very broad data structure. It's not really designed to store things in order, sequentially, or of the same data type. So if I run that, Python 3 dictionary basic 1, if I just try and print the data structure, you'll see that it just prints it out kind of plainly. A little bit like when you print out a list in Python, it just prints out all the values. So it does a similar thing here where it's like, yep, the name's Sally, the age is 18, the height's that. Now, I can also create a dictionary another way, which is by instead of creating an empty dictionary and then populating the values like I would a list, I can do it this way, where I actually populate the values while I'm creating it. So this is a way of saying I'd like to create a user data dictionary. These both, like these 4 lines here, have the exact same effect as these 5 lines here. I'm more just trying to show that they're equivalent. And Bill's asked why is in some, like what's the difference between these single apostrophes and these double apostrophes? The short answer is absolutely nothing. I just do that because I just try and show different examples to show that it really doesn't matter. So if I was to try and run dictionary basic 2, you can see I get the same output, but if I want to modify that dictionary, I could also do it the same way we just figured out before. I could say that user data name equals Hayden, like this, and you'll see that it will modify it. So we created it with Sally 18 and 187 centimeters. That's quite tall. And then I changed the name to Hayden and then printed out that user data like that. Yeah, that's all right. I just read chicken transcends genders on the thing. So Jimmy's asked a great question, which is why a comma, and I think he's probably asked it because it's written here. Sorry, which is this is just the way that the Python language is defined. Is that when you create a dictionary, you separate the values with a comma at the end, like this. So if I was to like not have these commas, then it wouldn't work, I believe. It would say like compile error. So you do need the commas, which you're probably used to as well from other types of data structures. But one thing that we're trying to flag is while you don't need a comma for the last element in a list or in a dictionary, what you will tend to do, and is generally, I think, considered good programming practice, is you always have a trailing comma at the end of your definitions. Now, it's like, why do you do this? Well, firstly, you tend not to do this if it's a inline list, right? Like, you don't do that. You don't do that, do you? The main reason that you put a comma at the end of these like multi-line definitions is because it makes your lines of code less fragile, in the sense that so someone said, what happens if I put another entry underneath like this? It makes sure you don't forget it, but also it allows you to be a bit more flexible. So for instance, let's say that you have something like this and then you decide to just delete that line, to just delete that line or something, or another line, it can cause chaos. So generally you just keep all the lines the same, ending in the comma. It's just consistent. It's pretty straightforward. I think it's a great language feature. It just doesn't exist in some languages because the language definition is different. If you create an empty dictionary, I don't think it'll even work with an empty comma, because I don't think you've even defined one element. Yeah, you'd have to define at least one element. So great. Okay. Now the next question is, how do you actually access elements in a dictionary? That's pretty straightforward. So if I've defined a dictionary here, and this is where things get a little bit more fun, what I've actually done here is I've actually defined a list of dictionaries. And conceptually, again, if you want to understand that, what I've said is that I've created a list which has 2 elements in it, like this. Like this is element 1, or like this is index 0 and this is index 1. And then inside each of these things are a dictionary with 3 elements. Sorry for my terrible drawing. Oh my god. Like that. So I'm now creating a list of dictionaries. Super easy to do in Python. Like Python is such a great data language. So I'm saying, okay, I've got 2 people basically. The first one's called Sally, very tall Sally, and the second one's called Bob, slightly taller Bob. Now that I've got that, if I just try and print that, if I just like print that as it is, it'll kind of print. It's just a bit hard to read, you know. So dictionary loop 1, oops, like this. It'll print it all out. It's just not a very useful thing. So we can actually loop over it just like we would loop over a list. So let's try that. Let's try and print out each user in user data. So simple for loop. In that simple for loop, it basically prints out the dictionary twice, right? Which is super useful. But what happens if we want to print out like each element of that? Well, the way we could do that is we could instead say, I just had this here, right? Print whole user is like that, and that'll print out each user. So that's 2 prints that are happening. But if we then want to go deeper, we can actually loop over the dictionary, right? Because user in this case is a dictionary. Because when we say for user in user data, we're saying go through the list, and for each of these, oh my god, that's a terrible color. For each of these items in the list, store that as user, which is a dictionary, right? Because these things are dictionaries. So if I want to loop over that dictionary, I can do so here, and I can say for part in user. Now what the hell is part? It's probably a little bit confusing. Here's one of the curious things about dictionaries. When you do a for loop over them, your list or array brain is probably expecting to get the values, right? Because that's what happens when you do a for range loop over a list. But in actual fact, in this case, you get what we call the keys, right? So every dictionary, this associative container that we talked about, is made up of keys and values, key and value. So what it's saying is the key height gives you the value 186. The key name gives you the value Bob. So when you loop over a dictionary, you actually get the keys. Because you'll notice when I try and print this out, I get name, age, and height, which is pretty strange, right? Like that's what this is showing us here. So then that leads to the question, which is, how do you actually get the values? Which we'll kind of go through here in a bit more of a detailed example. But there's many different ways of looping through a dictionary. So I've got an even simpler, I got a very simple dictionary here, which is just the same, you know, name is Sally, age is 18. Like this. And let's look at the different ways we can loop over these. I'll add a fourth one while I'm here. First one. What happens if we just loop over the dictionary like we would a list? Right? For user and user data, print user. Well, we're going to get the same thing we got last time, which is just the keys. Right? Name, age, and height. Now, someone pointed this out before. I can't pronounce your name because I don't speak. looks like Chinese, but I'm really stupid, so it might not be. It's not Japanese, I think, but I'm sorry. I'd love to know what I could call you. But Dictionary is not ordered person points out that dictionary is not ordered so that the loop in the dictionary is like a find, right? Yeah, so one of the weirdest things about dictionaries, which might break your understanding, is that, thank you, there is no sense of order, right? Like lists are ordered, 0, 1, 2, 3, 4, but dictionaries aren't ordered. There's no real sense of that name comes first, age comes second. It just doesn't really exist like that. This ordering that comes out is totally unpredictable. I mean, it's like it's probably going to be the same every time, but like if this makes sense, like if I add like a new element like user data A equals B, it's not always going to appear at the bottom. You know, sometimes it might appear at the top. You just can't rely on that fact, right? So if I print it out with the for loop, it just prints the keys, name, age, height. If I print it out with this .items property, right, which is getting a bit weird, basically we're saying, hey, can you get the items of user data? And we want to loop over that. Let's see what this one prints out for us. So this one's super interesting. What this one does is this one gives us, every time we loop over it, it gives us a tuple which contains the key and the value. Right, so it gives us the name and the value, and it does this just as a tuple, which is super interesting. In fact, let's see what happens if we just try and print user data.items. Let's see what this gives us. It's probably going to give us something weird. It's like, this is a little bit weird, but it makes a lot of sense. It's basically saying, if I ask for user data.items, it actually gives me a list of tuples, right? So instead of the complex dictionary structure, it kind of packages it up in a different way for me, in like a list structure, where it's like, hey, I'll just give this to you as a list with all the key value pairs as tuples. So it's a lot easier to work with. The other thing you could do is explicitly ask for the keys. So if you want to get all the keys in a dictionary, you can just do this. One thing you'll also notice here is that if you don't ask for keys, like the default behavior of looping over a dictionary is to loop over the keys. So lines 7 and lines 15 are the same. And then the third type of looping we have, or the fourth I guess, is to get all the values in user data. And you can probably guess what this is going to do, because it's like keys except you get the values. Now in general, in most cases, you'll probably prefer to do the method on line 11, because on line 11 you can do something like you could use an F string here and you could say, well, you could do this a couple ways. You could say, because it's a tuple, I'd like to print out user 0, user 1, right? Because it's an F string which allows us to use the braces to print out variables. Because user 0 is going to be the first element of the tuple, name, and user 1 is going to be the second element of the tuple. So that's how I could print this out a little bit nicer, right? So name, colon, space, user 1. We could also make this code even more readable if we want to by saying key value equals user. Because remember how in week 1 we talked about destructuring. And destructuring is the process where you take a tuple and you kind of like, what would you say? Like you break it up into its variables. So this code can actually now be easier to read. Because you're saying, yep, I get that user is a tuple, like up here, over here. But I would like to actually destructure it. I'd like to break that tuple up into 2 separate variables. And then I'd like to print them key and value. Indents. Goddamn indents. Miguel, you can. Yes, you can. I'm trying not to break too many brains today, but you're absolutely right. That's probably how you would do it. There's other ways to do this as well, no doubt. But that's kind of the problem with Python. This is what I was saying last week about. This is why I think that C is such a great first language to teach. Because even though like the vast majority of you will never really, program in C in your life properly. It's such an easy language. There's not like 6 different ways to print out a dictionary or something. Max says, why bother having tuples if lists can do the same thing but are less restrictive? I would probably pose the question back to you, what's the point of having constants if non-constant variables do the same and are less restrictive? Short answer is that sometimes restrictive things can be good because it avoids tampering. If there are things that are never going to change, why would you make them changeable? Is probably the underlying question there. So, this actually turned into a tute question, I believe. So, we're not going to do this in the lecture. But basically, and I think in week 2 or 3 tutes, there's a question. I think it might be week 2. There's a question on dictionaries, which is super useful. So you'll get to practice this more in the tutes and stuff. Scarlett says, when comparing 2 dictionaries, the order doesn't matter, right? Correct. Yes, that's correct. And Cap says, would print user data user work? Yes, it would. Yeah, so you just like up here that you can like if you print user data name like this, you actually get the name, right? Like Sally. But as you know, when you loop through user data, you get a list of the keys. So another way to do this, and good job Caps for pointing this out, is that instead of doing this one here, where you like get the key value, you can also actually loop over user data. I'll rename this to key though, so it's a little bit clearer, right? Because you remember that a for range loop over a dictionary gives you the keys. You could actually make this a little bit smarter by saying, I'm going to print the key, and then I'm going to print the value at that key. Like this. Like that. Because you see here, like if I want the value at the key name, I just write user data name. Right, like a struct. Like if you have a struct, you write like the struct's variable name dot name. That's how you get it. But in this case, because we're looping over keys, you can get the key and then you can get the value by looking up the dictionary at that key point. So that would actually be the same thing here. Generally, this is probably considered slightly cleaner, but it's much of a muchness, I think. And then Sarth has said, can you please show the structure of the dictionary user data? I'm not really sure what you mean, Sarth, because like maybe you're talking conceptual here, but I mean in reality the way a dictionary works is a dictionary is kind of like this giant blob where you essentially have like a key here, like name, and it just kind of points to a value over here called like Sally. And this is a bit of a simplification because every kind of associative container is implemented differently, but it's really just this big blob of keys pointing to values kind of thing. And the only reason we represent it as a blob is to remove the sense of ordering, because a list you visualize as a array something. But you asked about the structure. I mean, if you just print it, it shows you. It's like, here's the data structure. It's like that. I think that was done a few times. So while we're on a roll, I would like to very quickly touch on the globals lecture, because it's actually a really short lecture, I think. It'd be good to get this out. It's like 2 slides. Anyway, let's pause the recording.